Next is complementary slackness theorem. Consider the primal problem as this and dual problem as this, where x is n-dimensional vector, c is n-dimensional vector, b is m-dimensional vector, a is coefficient matrix of order m cross n, and w is m-dimensional vector. Let us consider x bar and w bar be feasible solutions to the primal and dual problem, then x bar and w bar are optimal solution to the respective problems if and only if these conditions are satisfied. That is, w bar transpose into capital A x bar minus b equal to 0 and x bar transpose into C minus A transpose W bar equal to 0. These above conditions are called complementary slackness condition. This theorem is both way theorem. That is, if these conditions are satisfied, then x bar and W bar optimal solutions to these problems. And other way, if x bar and W bar are optimal solutions to this problem, then these conditions are also satisfied. Therefore, these conditions are called complementary slackness conditions. This is the simplest form of complementary slackness conditions, that first we have to achieve the optimal table of primal, then we look in the optimal table of primal. If the decision variable xk appears as basic variable in optimal table of primal, then corresponding to this decision variable, kth dual constraint is satisfied as equality constraint. That is, slack or surplus variable associated with this kth dual constraint assumes zero value. The second is, if in the optimal table of primal slack or surplus variable sk appears as basic variable, then dual variable wk corresponding to this slack or surplus variable, dual variable wk associated with kth primal constraint assumes zero value in the optimal table. Now, this simplest form of complementary slackness condition I shall discuss with the help of an example. Now, I shall discuss complementary slackness conditions with the help of following example. Verify complementary slackness conditions by discussing the optimal solution of the LPP. This is given LPP. Minimize objective function this subject to these constraints with non-negativity restrictions. Take it as primal problem. Now optimal or table of primal is also given. This is optimal table of primal problem where x2, s2 and x3 are basic variable. This is z row. Now we have to verify complementary slackness condition. Before verifying complementary slackness condition, first let me find the dual of this LPP and the optimal solution of dual problem. First we discuss how to find the optimal solution of dual problem. This is the dual of this LPP. We already discussed how to find the dual of a linear programming problem. By that technique, we find the dual of this LPP. This is the dual of LPP. Now, before going into discussion of complementary slackness conditions, first I will discuss how to find optimal solution of dual from optimal table of primal. Now, optimal solution of dual problem is given by the formula CB transpose B inverse. What is CB transpose? That I have discussed, that CB transpose is basically cost coefficients of basic variables. What are the basic variables? Basic variables are x2, s2 and x3. That is x2, s2 and x3. Now find the cost coefficient of x2. What is cost coefficient of x2? That is minus 2. Therefore here we write minus 2. What is cost coefficient of s2? As s2 is a slack variable and cost coefficient of s2 is always 0. Therefore we take cost coefficient of s2 as 0. What is cost coefficient of x3? Cost coefficient of x3 is 1. Therefore, CB transpose is basically matrix corresponding to the cost coefficients of basic variable, which is as minus 2, 0, 1. Now, what is B inverse? That I have earlier discussed in my many videos, that B inverse is always lies below the starting basic feasible solution, as all inequalities are less than equal to type. Therefore, to change these inequalities into equalities, we add slack variable s1 here, slack variable s2 here, slack variable s3 here. Therefore, s1, s2, s3 are the starting basic variables, because identity matrix in the first simplex table lies below the S1, S2, S3. Therefore, S1, S2, S3 are our starting BFS. Now, B inverse is always lies below the starting BFS. Therefore, B inverse is 1, 1 by 2, 1 by 2, 0, 1, 0, 1, 1, 1. Therefore, we take B inverse as 1, 1 by 2, 1 by 2, 0, 1, 0, 1, 1, 1. After calculating this, we get minus 3 by 2, 0, minus 1. This is the optimal solution of dual problem. Therefore, we get value of W1 as minus 3 by 2, W2 as 0, W3 as minus 1. Now, this is the way how to find optimal solution from primal optimal table. This is the way. Now, we can find the optimal solution of dual directly without going to this formula from the table. If you look at the entries of optimal table of primal problem, look at here. Here entry is minus 3 by 2 in this Z row, and here entry is 0, here entry is minus 1. And our answer is minus 3 by 2, 0, minus 1. That means the optimal solution of dual is always lies in Z row below the starting BFS, starting basic feasible solution. As our starting BFS is S1, S2, S3, and entries of S1, S2, S3 in Z row is minus 3 by 2, 0, minus 1. Therefore, this is the optimal solution of dual. That is, optimal solution of dual is W1 is minus 3 by 2, W2 is 0, W3 is minus 1. We can find the optimal solution of dual either by this method, that is by taking CB transpose B inverse, or directly from the optimal table of primal. But second method, in which we find the optimal solution of dual directly from the optimal table of primal, is different in case we add artificial variable in the picture. How to find in that case, that I have discussed in that I will discuss in the last of my video. Now let us start to verify complementary slackness conditions. Our first complementary slackness condition is that if in the optimal table of primal the decision variable xk appears as basic variable, then corresponding kth dual constraint is satisfied as equality constraint. Now look at this optimal table of this primal problem. Here decision variable x2 and x3 appears as basic variable. Here decision variable x2 and x3 appears as basic variable. According to condition, second and third constraint should be satisfied as equality constraint. Now check this condition. Our second dual constraint is here, dual constraint. Our second dual constraint is 2w1 minus w3. Now we have the optimal solution of dual. W1 is minus 3 by 2 minus W3 is minus 1. This, after calculation, we get minus 2. Therefore, this second constraint 2w1 minus w3 is satisfied as equality constraint. That means if we write standard form of this, then we add slack variable S3, S2 here. The value of slack variable or surplus variable corresponding to this constraint is 0. That is, this constraint is satisfied as equality constraint. Now check the third dual constraint. Third dual constraint is minus 2w1 minus w2 plus 2w3. Now calculate this. Minus 2 times w1, which is minus 3 by 2. W2 is 0 plus 2w3 minus 1 equal to, after solving this, we get 1. Therefore, this third constraint is also satisfied as equality constraint. That is, if we write standard form of this, then slack or surplus variable corresponding to this dual constraint takes the value 0. Therefore, this is our first complementary slackness condition. That is, if xk decision variable appears in optimal table of primal, then corresponding dual constraint should be satisfied as equality constraint, as we show here that decision variable x2 and x3 appears as basic variable. Therefore, second and third dual constraint are satisfied as equality constraint. That means first complementary slackness condition is verified. Now we verify the second complementary slackness condition. The second complementary slackness condition is, if in the optimal table of primal slack or surplus variable appears as basic variable, then corresponding dual variable assumes 0 value in the optimal solution of dual. Now look at this. Here S2 appears as basic variable in optimal table of primal problem. Here S2 appears as basic variable in optimal table of primal. Now, according to complement slackness condition, if Sk slack or surplus variable appears in the optimal table of primal, then corresponding dual variable assumes 0 value in optimal solution of dual. As S2 appears as basic variable in optimal table of primal, this means W2 assumes value 0 in optimal solution of dual, which is true because here W2 equal to 0. Therefore, second complementary slackness condition is also verified. Now I shall discuss how to find the optimal solution of dual where surplus or artificial variable involves. Consider this linear programming problem. Take it as final problem. Here, to maximize this objective function, subjected to this constraints along with non-negativity restriction. This is the optimal table of primal, which is already given. X1, X2, S2 are basic variables. This is the Z row. Now we have to find the optimal solution of dual problem. First we find dual of this primal problem. Now dual of this primal problem is given by this. This I have already discussed in my videos that how to find the dual of a linear programming problem. In that way we find dual of this primal problem. Now we have to find the optimal solution of dual. As I earlier discussed, then one way is to find the optimal solution of dual is by the formula CB transpose B inverse. We find it here in the same way, CB transpose B inverse. First we find CB transpose. What is CB? CB is the matrix associated with cost coefficients of basic variable. What are the basic variables? Basic variables are x1, x2, s2, x1, x2, s2. Now note down the cost coefficients of these basic variables. Cost coefficient of x1 is -2, cost coefficient of x2 is -1, and cost coefficient of s2. What is s2? S2 is slack variable. Therefore, cost coefficient of slack or surplus variable is always 0. Therefore, we take the cost coefficient of slack variable S2 as 0. Now we write down the B inverse. Where B inverse exists, as I have earlier discussed, that B inverse always lies below the starting BFS. If we change the standard form of this LPP, then what is the standard form? Here we add artificial variable add1 in first constraint. Then here in second constraint we subtract surplus variable S1 and add artificial variable A2, and in third constraint we add slack variable S2. Now identity matrix lies below the A1, A2 and S2. Therefore our starting BFS is A1, A2 and S2. A1, A2 and S2. This is the starting basic feasible solution. Therefore B inverse lies below the columns of A1, A2 and S2. Therefore B inverse is 3 by 5 minus 4 by 5 1 minus 1 by 5 3 by 5 minus 1 0 0 1. Here is B inverse. After multiplying this we get minus 2 by 5 minus 1 by 5 0, which is the optimal solution of dual. That is W1 is minus 2 by 5, W2 is minus 1 by 5, W3 is 0. Now we directly find the optimal solution of dual from the optimal table of primal. But in case of artificial variable, if there is artificial variable, there is something different. What is different? Here W1, look at the Zj minus Cj row value of A1, that is m minus 2y. Take this Zj minus Cj value plus Cj value for artificial variable. Zj minus Cj value below A1 is m minus 2y 5, plus you have to add the cost value of artificial variable as cases of maximization, and in case of maximization the cost coefficient of artificial variable is minus m. Therefore we add minus m. After solving this we get minus 2 by 5, and then the Zj minus Cj value corresponding to A2 is m minus 1 by 5. Again we add the cost coefficient of artificial variable. Because of maximization problem, cost coefficient of artificial variable is minus m. Therefore we add minus m here, and after solving we get minus 1 by 5. And corresponding to slack variable, in case of slack variable always take the value directly. Therefore W3 is 0. Therefore in case artificial variable is in picture, then to get directly value of optimal solution of dual from optimal table of primal, we use in case of artificial variable this formula. In this way we get the optimal solution of dual, W1 as minus 2 by 5, W2 as minus 1 by 5, W3 as 0. This is the way how to find the optimal solution of dual from optimal table of primal. Now, utilization of complementary slackness condition is also seen by this question, Find the optimal solution of dual of the following LPP this without solving by simplex method. Given that x3 and x2 appears as basic variable in the optimal table of primal. Now, neither the optimal table of primal is given and nor we have to solve this by simplex method. How to find optimal solution of dual? Now we find the optimal solution of dual with the help of complementary slackness condition. Additional information is given that x3 and x2 appears as basic variable in optimal table of primal. First we find the dual of this problem. Dual of this problem is, now dual to this LPP is this, which we have already discussed how to get this dual from this primal problem. Now, as given that x3 and x2 appears as basic variables in the optimal table of primal. Now go to the complementary slackness condition. Then if decision variable xk appears as basic variable in the optimal table of primal, then corresponding dual constraint is satisfied as equality constraint. Now because of x3 and x2 appears as basic variables in the optimal table of primal, that means third and second constraints satisfied as equality constraint. As x2 and x3 appears as basic variable in optimal table of primal, therefore by complementary slackness condition we have second and third constraint as equality constraint. Second constraint is W2 equal to minus 6 and third constraint is 3W1 plus 2W2 equal to minus 18. Put W2 equal to minus 6 here, we get 3W1 equal to minus 6 and W1 equal to minus. Therefore, W1 equal to minus 2 and W2 equal to minus 6 and minimum Z star equal to, put it here, this is minus 6 minus 30, this we get minus 6 minus 30, minus 30. Therefore, by complementary slackness condition, we get the optimal solution as W1 equal to minus 2, W2 equal to minus 6 and the value of objective function as minimum Z star equal to minus 36. Therefore, this is another utilization of complementary slackness condition, how we can find the optimal solution of dual with the help of complementary slackness condition.
Friends, if you like this video, please subscribe our channel, then press the bell icon button to get notification of our new videos. Thank you friends.